So today's practice problems, we're going to be going over those from Unit 2, Lesson 10. The first one, which graphs could represent a proportional relationship? So a proportional relationship I know has two things when I look at a graph. It will pass through the origin, that's the first thing. So I can eliminate D, but I still have A, B, and C. The other thing that it has to have is a straight line. This does not have a straight line, so that leaves A and B. Okay, we're making lemonade. The recipe calls for a quarter cup of lemon juice for every cup of water. So then we have to answer these questions. So the first question, after looking at the graph, we need to decide what X represents. X goes up in these whole numbers, and that is clearly cups of water. The other piece of information that tells us that is the fact that for every 1x, there's 1/4 y, and we know there's 1/4 cup of lemon juice, so y is cups of lemon juice. The next question asks us if this is a proportional relationship. Well, there are a couple ways of telling us that. You can tell that for every full cup, there's a quarter cup of lemon juice, but also if I wanted to do the math to see what the constant of proportionality is, I know 1 times 1/4 works here, 2 times 1/4, 3 times 1/4 is 3/4, 4 times 1/4, so it clearly works. So is a proportional relationship? Yes. And if I wanted to just be very clear, I could say the constant of proportionality is 1/4. The last thing I need to do is plot those pairs in a table in a coordinate plane. So just quickly, I know that this is going to be my y, and this is going to be my x. So y is lemon juice, and x is water, and then I simply need to plot those points. So on our next page, you can see that that's been done. I know that it's dark. I don't like how it came out, but you can see that this over here is cups of lemon juice. Right there. And cups of water. And you can see that the points are very steadily going up in a straight line that passes through the origin. Okay, these tables we have to decide if each one could be proportional or not. So basically we're looking for a constant of proportionality. So we're going to look at dividing each of these. So the first one we'd have 3/2. The second one we'd have 6/4, which would equal 3/2. So far, the next one would be 7/5, which does not reduce to 3/2. So therefore, this is not proportional. The next one, again, we're deciding if this is a proportional relationship. In this case, I would say I'm actually going to divide in the other direction, which I know I tell you not to do, but because we're just making comparisons and we're not looking for the constant of proportionality, we can do that. So 20/6, the biggest gazinta is 2, so that would be 10/3. The next one is 45/9. The biggest gazinta is 9, so that becomes 5/1. Already I can see that this is not proportional. And the next one, I have to select all the pieces of information that tell us that there's a proportional relationship. Y is the distance between a rock and the turtle's current position. and x is the number of minutes the turtle has been moving. Well, the very first one is easy, y equals 3x. This is in my y equals kx format. So this is the next one. After 4 minutes, the turtle has walked 12 feet. Well, we could assume that it's constant, but it's not very clear that it is or not. It doesn't tell us that, so that one would not. The turtle walks for a bit and then stops for a minute before walking again. Well, that's clearly not a constant rate. And the last one, the turtle walks away from the rock at a constant rate. Well, that tells us very clearly, so this one is.